Right, so we're going to start by reviewing those couple test questions, and then we'll start on these notes. I just want this to be the first thing on the recording so that it shows up that this is actually the lesson on 3.1. Everybody okay? Got the worksheets? Okay. I'm going to jump to the questions that we didn't get to yesterday. At the end, we had 3 left to do. Is that what you say? Okay, I know... Whoop. Okay, this is one of them, but I think we did one like this in this class, didn't we? Yeah. What the trick is that we need to be careful that there's real coefficients at the end. It can be factored, but what would some of the factors be? Okay, it's going to have a 0 at negative 4i as well. What about the factors? Okay, and if you leave it there, you won't get full credit because some of those coefficients aren't real. Yes? They're imaginary, so if we FOIL just those two together, remember what happens? X squared plus 4ix minus 4ix minus 16i squared, and the minus 16i squared becomes... Okay. And then you can leave the rest of this, because it says factored form is fine, it just has to have real coefficients. Okay? It can't, if what you write down in that last parenthesis could factor, then you did it wrong, right? Because there wouldn't be imaginary solutions if it could factor, so be careful. The other ones that I wanted to talk about, were we good on the box? Yeah. Okay. All right, there's one like this on the test and on the summative, the post-test. Remember we did pre-test at the beginning, which is actually the post-test will be part of your final. There's one like this, okay, where there's a graph, and it asks you to explain these things. The reason for the explain part, and also on this problem it says explanation of how you confirmed your roots, okay? The post-test had to have a certain difficulty for a certain number of questions, and explain is something that they think makes it more difficult. I don't think it's going to make it more difficult for you. If anything, this question, I think the fact that it says explain the multiplicities will help you realize that there are some multiplicities in case you just went by them without thinking about it, okay? And I'm not expecting a paragraph, okay? The graph bounces at -2 and +4, so it has even multiplicity, or it has multiplicity 2, is fine. It doesn't even have to be a complete sentence, okay? With that in mind, tell me what you can tell about the zeros of this. Yeah, I should read the directions. It says, find the equation of the graph shown at the right. The scale of the x is 1. So it is telling you we're counting by ones this way. The scale of the y is unknown, but some point over here is at 264. So they're obviously not counting by ones up and down, right? Okay. So the zeros are at -2, 4, and 0, because it's going through here. Okay? When you write that, you don't have to write the multiplicities here. If you want to write for your own benefit, this one's going to have an even multiplicity because it's bouncing at -2, and at +4 it's also bouncing. You can write that, but you don't have to write that there. But here's where you're going to want to write something like, I know that, just say the bounce, where is the bounces?
-2 and 4.
And just say means that there's a multiplicity that's even, or you could just say 2, I don't care. All right? It doesn't have to be anything fancy. Now, that means we're at a point where the equation would look like x plus 2, x minus 4, and an x. What am I missing? Okay.
Make sure the right degree too.
All right. We have total of degree what right now? 5. Does this look like it could be a degree 5? Okay. It says show the work for K. Do you even know what they're asking there? I hope. We use A a lot instead of K, but it's the stretch. That's why this is here, remember? Otherwise we wouldn't care about that. So remember, we got to use that. X is 2, Y is 64. So we're going to do what? So 64 equals K times 2. 2 plus 2 squared would be 16. Does that sound right? 2 minus 4 back here would be negative 2 squared. Okay, so 16 times 4 is 64 times 2 is 128. Divide by 128, we don't get 2, we get what? 1/2. Now, how could you guarantee that you have this right? Plug it into your calculator. Now, is yours going to look exactly like that? Not if you don't figure out a better window, right? You could fiddle around and find a window like this if you want, but can you just go trace negative 2, trace 4, trace 0, trace 2, and make sure it's at 64 or whatever to find that you've got the right shape and the right ordered pairs? All right. This red box was the right answer under there, and that's what we have. We just wrote it different, right? Okay. I did miss a squared when I wrote it down here. Thank you. Okay. Then there was one other one here. We need to do all the possible rational solutions. Do you remember how we do that? All the factors of 12 over 4. So the factors of 12 are 1. I'll pretend I heard all those. And the bottom? Okay, so when we start putting those down, we have to write them plus or minus. Don't forget, if you forget the plus or minus, I have to take off something because essentially you're missing half of the solutions, right? Or possible roots if you don't have those. You don't have to list the positives and negatives separately, but you need to write me a list so I know that you understand what this mess meant. There's whole numbers. If you put them over 1, what else? If you put all those numbers over 2, which ones are not already on our list? 2 over 2, 4 over 2, 6 over 2, and 12 over 2 are all already on our list. And then we need over 4. Okay, 2/4 is a half. That's already on our list. 6/4 is 3/2, which is on our list. 12/4 is 3. We good? Okay. Use a graph in division to confirm which of the following are actual roots. So what are we going to do? We're going to graph it. And it's going to look like... Okay. And if I remember right, this is -4, and this is either 1 or 2. I'm thinking it was 2. I can't remember. But this is not a nice number. Does it have to be on our list? If it's not a rational 0, then it's either imaginary or irrational, and either imaginary or irrational zeros have to come in pairs. Do we have a pair to match up with that guy? So it does have to be on our list. I will tell you it comes between 0 and 1, so what could you try? 1/2, 1/4, or 3/4, right? Okay, it turns out if you do find the 0, it comes out 0.25, which means 1/4 is a 0. Okay? Some of you want to go straight to this. Does anybody know why that's not going to get you full credit? Yeah. It has to have, That's not going to multiply back. Factored form means it should multiply back to what we started with. That's not going to multiply back to this. Okay, because there's no stretch of 4. You could just throw the 4 out there. What I would prefer, because it wants work in an explanation, is if you looked on the calculator and you found one at -4 and one at 2, you went over here and you said, well, if I do the division and put in a 2, 4, 15, -52, 12, I'll see how badly I can mess this up. Alrighty, good start. Now, what does this mean? 4x squared. It does mean it's a 0 because the remainder was 0. And this factors 4x and x and 6 and 1 and minus and plus. So, yep, thank you. So if I had written down, I had a 2, positive 2, 0, so x minus 2 is a factor, and then I wrote 4x minus 1 and x plus 6, because I did the division, this would be great. This is perfect, okay? Otherwise, if you write it like this, you're going to have to go back and put the stretch in there, which is fine, but it's got to have that number. For your explanation of how you confirmed it, you could say I did synthetic division, the remainder was 0. I factored part of it, or you could just say I checked on the calculator and found all the zeros, okay? So, I'm okay. So you either graphed it or you divided and then factored, okay? No fancy words needed. All right. I can't think of anything else that we left off. Did anyone remember anything else? Review it all? Anything else? Okay. I do have a request tomorrow during the test. If you hear snoring from the front of the room, someone throw something at me, okay? I'm just because I'm so exhausted from watching all these Cubs games. I'm just dreading sitting here while you guys take a test tomorrow. Oh. Struggle. Yeah.
Take my test.
Yeah. Throw a book at me. All right, guys. This is the notes on 3.1. We need to start on 1B. It actually is because the front is just a review of exponent rules. Okay. I put this slide on here because it makes us sound really smart. It says in chapter 2 we studied power, radical, polynomial, and rational functions. I feel smart already. Okay. Then it says these are examples of algebraic functions. And it goes on to say we are going to explore exponential and logarithmic functions this chapter. These are considered to be transcendental functions because they cannot be expressed in terms of algebraic operations. In other words, they transcend algebra. So we're studying transcendental algebra now. Do you feel like we're on a whole other plane or something?
I feel like I'm in England.
All right. This is the big deal, guys. We studied x to the third. Now we're studying 3 to the x. Exponential, that's all that means. That the exponential function is when the exponent is a variable or has a variable in it. All right? Exponential function means there's a variable up in the exponent. Logarithmic function was developed so that we could solve for the x up in the exponent. All right, today we're going to study exponential functions. There's examples down here and they're super tiny. I don't know if I can make this. I'll just make it bigger so you can just see those for a second. All these down here have x in the exponent. You see that it's okay for x to be negative, have a fraction. What it can't be, okay, that says 5 to the pi because pi is not an exponent. And this says 1 to the x. It says here b can't be 1. Think about that for a minute. If you multiply by 1 over and over and over, is it going to grow or decay? You're just going to get a horizontal line. So it actually turns out to be like a linear function. All right. These are your notes. So an exponential function is anything that can be written in this form. This is going to be like when you put in a b, or an x equals 0, b to the 0 will be what? Anything to the 0 will be 1. So this is going to be the value where it crosses the y-axis. If b is greater than 1, so, all right, here's my example for the day. I gave you 100 M&Ms. If we multiply that by 2 every hour, is it going to grow or decay?
It's going to.
I'm going to give you twice as many M&Ms every hour, right? So you're going to have twice as many on your desk, okay? If it is decaying, you would be multiplying by this, which actually would mean there's only 1/4 left after every hour, okay? So you're eating 3/4 of them, or throwing them away. That should be a sin. Okay. So there's this, when this value we're multiplying by is greater than 1, its growth, less than 1, its decay or going down. Seem okay?
Yes.
All right. These are the graphs. Growth, does this make sense? It's getting bigger. Decay, it's getting smaller and smaller. Okay? These don't necessarily hit at the same places, except that if you don't have any shifting or stretching or flipping, they will always go through 0, 1, and we just talked about why. If you put a 0 in here, it will always go through whatever A is, okay? If A is just 1, then it's going to be, it does say that up here, it says when there's an A, then you'd have 0A instead of 0, 1. All right, domain and range seem okay? Make sure you understand that they are not negative unless there's some kind of a flip or reflection involved. And it's a soft parenthesis. They are approaching but not touching the x-axis, which is the equation y equals 0. They have no max or mins. They are always, this one is always increasing, this one is always decreasing. They are continuous. This one is on the left end approaching 0, right end infinity, left end infinity, right end 0. Any questions? All right, on a test or a quiz, I will generally only ask for the x and y intercept, domain, range, and maybe end behavior. Asymptote can be tricky. If the graph has shifted, flipped, stretched, you can usually get some points and figure out what the asymptote is on the calculator, but it's a little tricky, so it's not something I will ask probably. All right, we start out with a tricky one. Not really. But you got to think about this. Part of this calculator, part of this test, everybody listening? When we have the first quiz on this unit, this new unit, the first quiz has 2 parts. One is no calculator, as in none, 0, zilch. Okay? Because when we start logs, I need you to understand what that means. This means 2 to some power equals 8, and I need you to be able, I'm not going to use huge numbers you can't do in your head, but 2 times 2 times 2 is 8, so the answer should be 3, okay? I need to be able to know that you understand some of this without a calculator in your hand to do it for you. All right. This question, if I asked you to graph this without a calculator, there's a couple graphing questions. 1/3 to the 0 power would be what? Anything to the 0 is 1. To the 1 would be 1/3. But what does the -1 exponent do?
3.
It flips it upside down. We good? Okay. So there's 3 points right here, here, and here. I don't have a cursor. There we go. And from that, you could also find more points. If you squared it, you get 1/9. What would it be to the -2? Flip it over and square it, so it would be +9, so it's growing very quickly. So you need to know the general shapes that these can be, and then you just need to be able to find a couple points. All right, let's try this one together. This is kind of complicated, but we're going to start by talking about, we're going to start by talking about this. Can you tell what shifts or transformations have gone on here? Let me write this down as a review. Somebody dropped something upstairs, but it scared me half to death. If this was a parabola, what would have happened? The vertex would have shifted right one and up one. The same thing is happening here to the parent function 2 to the x. Shifted right one horizontally, and vertically it shifted up one. Just write right one and up one, I don't care. All right, now let me go back. That was kind of reviewing the concept. Help me find 3 or 4 points on this graph, 2 to the x. If I put in a 0, 2 to the 0 is, so a point is 0, 1. If I put in a 1, 2 to the 1 is, so it goes through to 1. No, 1, 2. Just kidding. What if I put in a negative 1? So I get negative 1, 1/2. Does that seem like we could handle what the idea is looking like for the graph? Okay. What is going to happen to our graph is that it is going to shift right 1 and up 1. All 3 of those ordered pairs can just be shifted right 1 and up 1. We can put in some values, but I just want you to have an idea what it's going to look like, okay? So if I put in a negative 1, help me think about this. The exponent would be negative 2. What is 2 to the negative 2? 1/4. Anybody agree, disagree? 2 squared is 4. Negative flips it over. So 2 to the negative 2 is 1/4. Plus 1 would be 1 1/4, or 1.25. Don't matter. Okay, put in a 0. 0 minus 1 would be negative 1. 2 to the negative 1 would be 1/2. 1/2 plus 1 would be 1.5. What if we put in a positive 1? 1 minus 1 is 0. 2 to the 0 would be 1 plus 1 would be
2.
Okay, one more, put in a 2. 2 minus 1 is 1. 2 to the 1 is 2 plus 1 is, okay, negative 1, 1.25, 0, 1.5, 1, 2, 2, 3. We get an idea? The asymptote is usually what throws students, but if this was the asymptote and we shifted right 1 and up 1, what should be the new asymptote? Yes. Y equals 1. The left-right shift doesn't do much. It changes our y-intercept, but that's about it. I will tell you, if you were to graph this on the calculator, it will look like this. It'll look like it ends right here somewhere. The reason for that is the calculator could only make this a straight horizontal line, and it doesn't like you to think that it's perfectly horizontal because it's really not. It's getting closer and closer. So sometimes the calculator just stops it rather than mislead you, which is misleading in and of itself, right? All right, what are we missing over here? We should draw this going this way, but domain, anybody? Left to right? Okay, range, bottom to top. Good call. The intercepts, it only crossed the y, and that was at 0 and 3/2, or 1.5. The asymptote we already said was y equals 1. Okay, what's it approaching on the left?
1.
The y value is positive 1, yes? On the right, the y value is, yeah, it's going up. Just be careful. I don't want you to get confused with tomorrow. This said describe the end behavior in the directions. Tomorrow, remember, we're doing find the end behavior equation. That's different. You hear those words and yes, like it's either a horizontal asymptote or you had to divide and find the end behavior equation. But don't write this. Nowhere on the test, I don't think, does it ask you to do this, okay? If it did, it would be probably written out for you. All right, this entire graph is increasing, so all of it is going up. All right. The second equation on your sheet has an E. So I just wanted to give you a 20-second view of what E is.
0.2.
Yeah. No.
0.2.
Oh, before we get to that, sorry, I thought I had this in a different order. We just talked about this. X plus 1 would slide this which way? This would be left 1. Anybody know what 2 to the negative x, what does the negative on the x do? Yes, it's reflect over y. So it would look like, do you see what they did here? Reflected across the y, yes. Think about that. Isn't 2 to the negative x the same as 1/2 to the positive x?
Yep, pretty much.
Okay? Do you understand that or not? Do you understand that? This is 2 to the negative 1 to the x, which is 1/2 to the x. So it really becomes a decay. All right, this guy was multiplied by a negative 3 out front. A negative 3 on the whole thing reflects it over what? Reflects over the x-axis, so it becomes a negative. And then it was stretched a little bit, so instead of crossing at negative 1, it crossed at negative 3. All right, back to my talk about E. I put in a slide here explaining E is actually called Euler's number. It occurs often in nature. Things in can be used to describe things that are growing or decaying exponentially when they continually are growing or decaying. This is the definition that I usually use to teach how they find that number. If you have 1 plus 1 over n all to the n, and you put in a 1, a 5, a 10, a 100, a 1,000, a 10,000, a million, it gets closer and closer. Do you see what it approaches? This magical number that's 2.71 something, it's E, okay? So what it said is that this is E is the limit that this number will approach. Just weird. Okay, it's just some number. It's roughly 2.7 is what we need to know to graph this problem.
It's weird.
All right, here we go. So the parent function here is actually y equals e to the x. But let me ask you this. What's the difference between this and this that we did a minute ago?
E is 2.718.
Yeah. Is the shape different? This is growing by 2. This is growing by 2.7.
Slightly different.
Yeah. But it would have the same values except like here at 1, this would be 2.7, and at 1, this one was 2. Same shape. But what's this negative out here going to do? Do you remember what we said?
Flip it. Make it look like a
Over
decay.
what?
Y.
Yes, reflect over the y-axis.
Decayify.
It's decayified. I like that. All right. Rather than spend a whole bunch of time thinking about this and doing crazy things, let's practice what you guys are actually going to do on a test or quiz. Type it in your calculator, okay? Type in y equals e to the negative x. I'm not going to ask you to graph an E1 on the test without a calculator, I promise. And then go to the table and find like -1, 0, 1, 2, -2, some of those values. If you put in a 0, you should get 1. If you put in a 1, do you get like 1 over e, which is 0.4 roughly? Am I okay? Anybody get that decimal? Yes, Morgan's. If I put in a -1, because this becomes minus -1, it's actually just e, which your calculator will have like 2.7 for -1. Yep. We okay? What about if you put in a 2, I'm thinking it gets even tinier, yes? 0.1. And if you put in a -2, is it like 7 point something?
7.389.
Only because I've done this question 3 times a day, not because I know what that is. Okay. Over 0, up 1. Over 1, up 0.4. Over 2, up 0.1. Left 1, up 2.7. Left 2, up 7.3. Okay. We get the idea that it is looking like a decay. And the domain, anybody? The range, bottom to top. The intercept, the only intercept is 0, 1. Yep, you were on the right track. The asymptote, you can either write the x-axis or what's the equation of that? Y equals 0. End behavior. Left end is infinity, right end is approaching 0. Good job. Increasing or decreasing? Okay, it is decreasing from -infinity to infinity. I will not ask you increasing, decreasing. Probably won't ask asymptote either, but it's possible if it was a basic one. Okay, if it's been shifted up, down, left, right, stretched, yeah, probably not going to ask. All right. We need to know these 3 concepts. You have been doing this since Algebra 1. Exponential growth or decay, you were taught, is the original value times 1 plus or minus some rate of increase or decrease to the time. So let me give you an example of what you did. You said there were 2,000 people at Harlem High School. The population was decaying, or there were less students every year by 4%. So you would do 1 minus 0.04. And what would the population be 10 years from now? You'd put a 10 there. Does that sound very familiar, I hope?
Yep.
Okay. That's when it just says exponential growth or decay. Growth is plus, decay is minus. And the rate has to be a decimal, percent. Take the percent symbol off, move it 2 places to the left. When you see the word continuous, you're looking for an E. That's the hint you're using this formula. This is the one that will be on the next quiz, is PERT. P actually stands for principal, but most of us think of it as present value. It's what you started with. I think I might let you use a formula sheet, but you'll have, if you do your homework and take the notes, you'll have used those 3 formulas enough, you'll be fine. I promise. But A is future value, or the amount in your account. R is still a decimal. Now, interest can't be negative, but this idea is the same here. We do a question in a little bit that says it's continuous decay. Continuous decay, you use a negative rate, just like we did over here. If it's decaying 4%, you would put a negative 0.04 in for R. When we do it as interest, it's not going to decay, but this formula is exactly the same when it just says exponential decay that is continuous. You only use these when it says the word continuous. And here time is in years, if I didn't already say that. Okay. Last one over here, this is compound interest. If we put $500 in an account, it's earning 6% annual interest compounded monthly. Then you would say it's earning 1 plus 0.06, but you don't get 6% every compounding every month. You have to divide that out over the course of the 12 months. But compound interest means they're putting it into your account every month so that that interest is then earning interest. Okay? So you're earning that 12 times a year they're going to do that compounding. And if we would say I'm going to leave it in there 5 years, then you would do times 5 up here. When you type that in on the older calculators, you have to do 1 plus. You don't need an extra parenthesis over here. But then to the power of here, you would do 12 times 5 with a parenthesis around that part. All right, ready to try some examples? Yes.
What, when they say, I mean, obviously there's a difference in the equations for continuous exponential growth and decay and exponential growth and decay, but like, what actually is the difference? Like, what would you define as not continuous versus continuous?
You will see the difference here. Continuous means it's like continuous interest. It's being continually, in theory, added into the account. So it doesn't wait until the end of the period to double. It's continually growing. If you said it's going to double in 6 years, it's actually growing along the way until it has doubled after 6 years. If you say you do the exponential growth until you hit 6 years, it's staying at the original value. If you said it's going to double in 6 years, it would stay at the original value until the 6 years was up. That's kind of the idea, okay? This is a compound interest question that you'd have to have magical eyesight to see, but it says here there's $300, 1 plus 0.06 over n to the 20n. This means you're leaving your money in 20 years. It's compounding a different amount of time every time we use the charts. It's at 6% annual interest, and you put $300 in, okay? If you compounded it only once a year, you'd have this much money. Semi-annually is the word, that word would mean divide by 2 and put a 2 out here. It grows, okay? Quarterly, the more compoundings you do, the more the money will be worth at the end, because your interest is earning interest. Does this sound familiar? Okay. Daily, you put in a 365 that you're dividing by and multiplying to an exponent power. Hourly is basically continuous. This is the continuous interest formula. So would someone type this for me? 300 e to the, okay. I like to use the E button, and I recommend you do. That's on the left side of your calculator, 2 up from the bottom. It's ln, so if you do second and then that E button, it brings up the to the power of for you, and we're going to need to put in there 0.06 times 20. 196.035. Okay, so basically it's this. Maybe you round it up to 0.04, right? Because continuous interest just means they're putting the interest in at a little bit more often, and so it's even more than hourly. Okay? They want you to do this to see and understand that, well, the more compoundings will make it grow more. The more you compound doesn't like double the money or something. It just approaches a value. Banks actually use continuous interest most of the time, so it's the same. Yeah, I don't remember what 6% on that question. Is that what it said? Yeah. Well, you know what? It all changes. Back in the day, at one point I bought a house at 12% interest because that's what it was. That's what the mortgage rates were back then. Everybody paid it. My student loans were at 9%.
Oh my gosh, that's so high.
All right.
How did you pay for that?
It is. That's what the economy was. So it's just a different day. All right, guys. A quick question here. Researcher estimates the initial population of cells at 100. It's growing at a rate of 25%. What do I put in the parenthesis? 1 plus 0.25 or just 1.25 would be fine. This said per week, and it wants to know in 6 weeks, so our exponent is just 6 because we didn't have to do anything crazy. It just said weeks and weeks, just a power of 6. Where does that 1 come from? That's the way I think of it. You're keeping 100% plus another 25%. Does that make sense, guys? If you just put the 0.25 in there, would it grow?
No.
It would go down. You'd be multiplying by a fourth every time, right? So to make it grow, you need all of it plus some more. So that's 100% plus the 0.25. That's how it makes sense to me. All right, somebody type that one in. 381. Is it right? Oh my goodness, can't remember. Believe I remember that number. That's a situation where it seems appropriate to me to round to the nearest whole number, because I don't know how many hundredths of a cell I could identify, right? The next question is about money. What is an appropriate place to round a question about money? 2 decimal places, hundredths for pennies. Seems right to me. When I go to the bank, I expect them to give me every penny of my money, right? All right. This says compare the difference between compounded continuously. Yes? No? Just continuously. That's all we have to do. All right, I was reading. The next one, I think, is a compare question. So we're putting $1,000 in. What's the formula we use for continuous? The PERT?
A equals PRT.
Okay, so our current account is the A. Then it's, or the P, I'm sorry, the present value. Times E to the what? Can you read the question and help me out?
The rate is 5%, 0.05.
Okay, 5% is 0.05 times the time, which is just 10 years.
Just 10 years. 10 years is 25.
Okay? 5%, 10 years, made $648.72 in interest. Say that again? Oh, there is. Thanks, yeah. All right, guys, this is the compare question. We're going to do this twice. We're going to put $5,000 in continuous interest and the same $5,000 in compounded quarterly. 2 different formulas. What's the continuous going to look like? 5,000 times? Okay, what do you got to do with 8.5%? 0.085 times, are we still doing 10 years? Okay. Anybody got that one for me?
$11,698.23.
Okay. All right, we haven't done one with compounded quarterly. Anybody know what that's going to look like? Oh, 5,000. Yep, that's what that meant. Anybody remember how it goes?
Times 1 plus 0.085. Yeah.
Quarterly.
Divided by 4.
4 times a year for 10 years, or to the 40th power. This is the total number of compoundings over here.
Uh-oh, I forgot.
5,000, parenthesis 1 plus 0.085 divided by 4, close parenthesis, to the 40. Okay, I got 11,594.52. When it says compare, you need to somehow compare those numbers. I would probably subtract. Yeah, so continuous interest earned, I don't know, I have no cursor, so I'm just crazy writing here, about $103.71 more in 10 years. All right, we will finish the notes, but you are now ready, guys. Seriously, you're ready to do this assignment that is listed on the worksheet here, page 166. It's not as long as it looks, okay? Because some of them are just like, tell me it shifted 3 to the right. That's all you gotta write. What are we doing? Is it okay? Are you doing okay getting caught up in trig too? Have you missed trig?
Trig is going well.
Okay.
I think trig is easy.
Okay.
So, especially compared to this, I think trig is easy. So.
Okay. I don't think you're really having trouble with this, are you?
No, not really. It's
Okay.
just the homework that's been dragging
Yeah.
my grade down. So, thank you for responding to me. I still have 2 teachers who haven't responded.
No worries. If that's what's dragging your grade down, and then I have no problem no counting.
Okay.
Okay. As long as your test and quiz average is good, we're good.
All right. Thank you.
Thank you. You too.